Good evening.
Good evening, sir.
Any doubt from last class? Okay, in last class I defined you. Just 1 minute. Up to this part, that is equation of traveling wave. And I defined you different term related to this part. That is relation between particle velocity and wave velocity, particle acceleration, and displacement. Next, there will be a relation between phase, path, and time difference. As general equation, of displacement of particle in a wave is a times sine omega t minus of kx. So this particular quantity, that is angle of sine, is called phase. Let's say this is phi. So we can write phase phi equals to omega t minus kx, which is depending over two different parts. First is time dependency and second is x dependency. So in first case, let's say t is constant. In second case, let's say x is constant. So I'm putting for first value, phi 1 equals to omega into t minus k times x1. Since time is constant, so it will not change. Again, phi 2 will be omega times t minus k times x2. That is, phi is changing with respect to x only. So if you subtract these two parts, so it will be phi 1 minus phi 2 equals to this part and this part will cancel out. So you'll get k x2 minus x1. This particular term is also called change in phi equals to k, and this particular term is also called delta x. So it may be written as k is equals to 2 pi by lambda multiplied by delta x. So this is first relation between phase difference with respect to path difference. Mamuna, is it clear?
Yes, sir.
In second case, suppose x is constant. So phi equals to omega times t1 minus k times x, and phi 2 equals to omega times t2 minus k times x. So on subtracting these two parts, minus, minus, and plus, these two terms will get cancelled out. So you will left with phi 1 minus phi 2 equals to omega being constant, keep it outside, t1 minus t2. This term will be phase difference and this term will be time difference. So delta phi equals to omega times delta t. We may write omega in terms of 2 pi by t multiplied by t, or in terms of frequency 2 pi into nu times delta t. So in this part, this is phase difference and this is time difference. So from this part, we can find phase difference with respect to part difference or time difference as well. Is it clear? Matthew, any doubt?
No, sir.
Okay, just write it down. Matthew, done?
1 second. Yes, sir.
Using the above question, if fxt is 0.04 sine pi times t minus pi by 4 times x. Find phase difference. First, delta x is 2 meter. And second, t is 0.4 second. Just use the above concept and try to find. From this relation, we can say coefficient of t will be omega and coefficient of x will be k. This is new for frequency. So in first case, to find delta phi, it will be equals to k times delta x. And coefficient of x from this particular equation will behave as k. In second part, delta phi equals to omega times delta t. Omega will act as coefficient of t in the equation. So this will act as omega and this will act as k. Just put their values and simplify it. Mehreen, any doubt?
No, sir.
Ramona, you got any answer?
No, sir, I'm doing.
Coefficient of x in this above expression will act as k. So k we have pi by 4 and delta x we have 2. So this and this will cancel out in 2 times. So phase difference in this will be just pi by 2. Similarly, in second part, coefficient of time will be omega, which is pi, and delta t, time difference, we have 0.4 second. Just remove this decimal and write 10 in place of it. So 2, 5. So you'll get 2 pi by 5. So this is how you can solve phase difference with respect to time difference and part difference. Matthew, any doubt? Okay, just write it down. Have you all done?
Yes.
Yes, sir.
Next is reflection of wave. Suppose on a wire or a string, a pulse is created like this, which is connected to any movable support at this point. This is incident wave along this direction. So what will happen on striking this particular surface? So you will say, since this particular end is free to rotate, it is movable. So on reflection, there will be no change in its direction and its energy. So it will get reflected along same direction. So this is incident wave, and this is reflected one. It means if the surface on which pulse strike is free to rotate or smooth, then there will be no change in its direction. It will get reflected along same direction. But in second case, if surface is rigid and a pulse is incident along this way, and if this is rigid or fixed, so this pulse on reflection get reflected back, but in opposite direction, like this. So this is incident ray or incident wave, and this is reflected one. These two different terms is based on whether the connected surface is free to rotate or it is rigid or fixed. Is it clear? Okay. Using this concept, let me define you. First, write it down. Then I'm defining you. Have you all done?
Yes.
Matthew, done?
1 second, sir. Yes, sir.
Okay, let me explain you again this part. And first, if you have any string which is connected to this particular support, but this end is free to oscillate. So if this particular pulse strike at this point, then on get reflected back, the direction of these two terms will be seen. So you'll be asked, what would be the phase difference between these two terms? So you will say 0. So in this part, we can say phase difference is 0. Only difference is direction of propagation. First, incident pulse is going towards positive x-axis, but reflected one is going towards negative x-axis. So there is change in its direction of traveling. But in second part, if it is connected to any rigid support, then if this particular pulse strike at this particular point, since there is no any movement at this end, so it gets reflected but in opposite direction. It means phase difference between incident one and reflected one will be pi. Is it clear to all of you?
Yes, sir.
So using this concept, let me define you stationary wave or concept of stationary wave. So next is stationary wave. Suppose a string is connected to this end by rigid support and again this end by rigid support. So this particular wave is directed along this way. Let's say this is y incident. So on striking this particular surface, it gets reflected back, but in opposite direction using the above concept. So it may get reflected along this way. So if you extend this particular wave downward to define phase difference between two parts. So this wave is going along this way, and this is along this way. They two are differ in phase by pi. Is it clear?
Yes, sir.
Just 1 minute. If you draw a tangent at this point, since it is proceeding along this way, so curve will be along this way. And similarly, if you draw a tangent along this way, so these two projection differ by pi. So we can say incident wave and reflected wave differ in phase by pi. Matthew, is it clear why there is phase difference of pi? Okay, so we have to calculate this particular entire term mathematically. So let's say y incident going along positive x-axis which having amplitude A times sine omega t minus of kx, since it is going along positive x-axis direction. So this is incident wave. So after reflection, its direction will change and its phase difference will be pi. So on a striking, fixed support phase and direction will change. So now y reflected will be A times sine omega t plus kx, since it is going along positive negative x-axis. And these two are opposite in phase by pi. We may write this, or we may write it as A times sine omega t plus kx. Both are same. Since sine pi plus theta is minus of sine theta. So using this, we may write it as this. Mehreen, any doubt?
No, sir.
So this is equation of reflected wave. And since these two waves are just adding over one another, so let me define you superposition of these two terms. So on adding, y equals to y incident plus y reflected. Y incident, we have A times of sine omega t minus kx minus A times sine omega t plus kx. So how to add these two parts? Let's say this is C and this is D. So using a formula, sine of C plus sine of D is equals to 2 times sine C plus D by 2 multiplied by cos C minus D by 2. I'm considering this particular term to be D since it is smaller as compared to this part. But in this, we have sine C plus sine D. But in this above part, we have sine C minus of sine D. So in terms of minus, then there will be just opposite of it. Just 1 minute. So it will become cos and it will become sine. And since C is negative and D is positive, then there will be negative sign in this part. Is it clear?
Yes.
First, write it down to this part, then I'm defining the rest down.
Yes, sir.
Matthew, done?
Yes, sir.
Any doubt up to this part?
Not really, sir.
Okay. So using this, if you simplify the above part, you will get y equals to, let's say a being constant, keep it outside. So sine C and sine D, it will become 2 times with some negative sign cos C plus D by 2, that is omega t plus kx plus omega t minus kx divide by 2 times sine C minus t, that is omega t plus kx minus omega t and plus kx divided by 2. So this part and this part will cancel out. Omega t and omega t will cancel out. So in first part, omega t is 2 omega t divided by 2, it will be just omega t. In second part, kx, 2kx divided by 2 is just kx. So on solving, you will get minus of 2a sine of kx and cos of omega t equals to y. This is general equation of standing wave. In this part, we have two different terms. One is time dependent, which is just separate as that of the other, which is x dependent. So we can say this particular equation is general equation of standing wave or stationary wave. In this part, this term will define you oscillating particle with time dependency, and this term will define you its position. Is it clear?
Yes.
So this is equation of stationary or standing wave. Using this, let me define you this particular curve. We have two different points. One, which having maximum amplitude or separation of particle, and the other which having minimum amplitude of particle. So this point is called node, and this point is called antinode. Fawaz, any doubt?
No, sir.
Okay. So using this particular equation, we have to define position of node and antinode. This particular term will have different value at node and antinode. Let's say for node where amplitude is minimum, that is 0. So in this coefficient, 2a will never be equals to 0. So the rest of the thing, that is sine of kx, will equals to 0. In general, sine n pi will equals to 0 and sine 2n minus 1 pi by 2 will equals to 1. You may remember this particular relation. So using this, we may write it as kx is equals to n pi, or x is equals to n pi by k. Knowing this value, you may define position of node on this particular entire string depending upon the value of x. Similarly, for antinode, where amplitude is maximum, so sine of kx will be maximum. It means kx will be equals to 2n minus 1 times pi by 2. So position of particle will be 2n minus 1 pi by 2 k. Mamuna, any doubt?
No, sir.
Okay, just write it down.
Done, sir.
Matthew, done?
Yes, sir.
So if you transform this particular k as 2 pi by lambda, so you may write x is equals to n lambda by 2. So on putting the value of n, it will be lambda by 2, 2 lambda by 2, 3 lambda by 2, and so on. Similarly, in this part, x is equals to 2n minus 1. If you put k to be 2 pi by lambda, you will get lambda by 4. So if you put n to be 1, so it will be lambda by 4. N to be 2, so it will be 3 lambda by 4, 5 lambda by 4, and so on. So these are different points on which you will get antinode And this will be a different point on which you will get node. So these will define you position of node, and these will define you position of antinode. Now, first question related to this part will be, you will be given if y equals to 0.06 sine of pi x and cos of pi by 4t. Is it traveling or stationary wave? Second, find amplitude of actual wave. Third, velocity of wave. Let me define you how to analyze whether it is stationary or traveling wave. Above, we have learned two different equations. First is y fxt, any particular variable, may be represented as a times sine omega t minus of kx. But in this part, we have y equals to 2a times sine kx cos omega t. So we can say if omega t and kx both will be in same bracket and within the same function, then it will define you traveling wave. Will define you stationary wave or standing. Is it clear?
Sir, can you repeat?
If omega t and kx both are written in combination of one another within the same bracket and having just one function, then we'll define you equation of traveling wave. But if kx and omega t will define for different function and they may be written separately, then it will define you equation of stationary or a standing wave.
Okay, sir.
So from this part, we can say this is condition of traveling wave and this is condition of stationary wave. Mamuna, is it clear? Matthew, any doubt?
No, sir.
Now just tell me about this particular equation. Is it stationary or traveling wave? This part?
Sir, stationary wave.
Good. Since in this part, we have two different function. So kx part and omega t part are in separate manner. So this will define you stationary wave. So in case of a stationary wave, the resultant amplitude, that is this, will be twice of its actual amplitude. So if you have to calculate actual amplitude of individual wave, just divide it by 2. So in first case, you will say it is stationary wave. In second part, you have to calculate amplitude of actual wave. So it will be just half of it. That is 0.03 meter. And third part, if you have to calculate velocity of wave, which is nothing but omega by k. How to analyze omega and k? Omega is coefficient of t, that will be this, and k is coefficient of x. So omega we have pi divided by 4, and k we have just pi. So it will be 1 by 4 or 0.25 meter per second. Is it clear to all of you?
Yes, sir.
Abdul Wahid, any doubt? Okay, just write it down. Have we all done?
Yes.
Matthew, done?
Yes, sir.
Okay. Now, with respect to this stationary wave, rest of the thing, that is stationary wave on string, stationary wave in organ pipe, rest of the thing is deleted from your syllabus. So next is beads, the last part of this chapter. Rest of the whole thing is deleted. So first, what do you mean by beads, or how it is produced? Let me define you. Suppose we have string on which there is a wave. Let's say this is A, source first. So if I ask you, what will be the frequency of this particular wave? So just count number of complete oscillation it have. So you will say 4. So let's say its frequency is 4 hertz. It means in 1 second, it will complete 4 complete oscillation. Now suppose there is another wave This is another wave. Let's say this is B. So if you calculate number of complete oscillation in this part, we have 2. So let's say its frequency is 2 Hz. So on superposition of these two terms, it means on adding these two terms, what you'll get? First, since direction of this wave and direction of this wave are in same, but in this point, which is going up, but this going down. Similarly, at this part, it is going up, but at this point, this is going up and this is going down. So initially, both are in same direction, so it will tend to add. So resultant of this part will increase to its maximum up to this point. Now at this point, both are in opposite direction, so it will tend to decrease. So it will reach to minimum. Then further, both are in same direction, that will tend to increase. And then it would decrease to minimum. Similarly, we can define in opposite direction as well. In first part, frequency of A is 4 Hertz and frequency of B is 2 Hertz. So in this part, we have two complete oscillation, that is this one, which is F1 minus F2. There will be another wave in it, which is equals to sum of these two terms. Just 1 minute. This is F1 plus F2. Where amplitude is maximum, then it will define you loud sound. And if amplitude is minimum, it will define you faint sound. And similarly, this one is faint sound. The combination of loud and a faint sound is called one beat. Similarly, combination of one loud and one faint is called beat. So from this part, we may define beat as if two waves having different frequency propagating along same direction, so on overlapping, they will produce combination of loud sound and faint sound together. This combination of loud and faint sound due to superimposition is called beat. Is it clear?
Yes, sir.
Matthew, any doubt?
No.
Okay, just draw this particular part. I will define you this mathematically also.
Done, sir.
Matthew, done?
Yes, sir.
So from this part, we can say when two waves of different frequency propagating in same direction superimpose over one another produces combination of thin and loud sound. This combination is called beats. And the number of beats produced per unit time is called beats frequency. So how to calculate beat frequency mathematically? Let me define you. Let's say first wave is A times sine omega 1 into t, having frequency f1. So you may write it as A times sine omega is 2 pi f into t. And next equation, A times sine omega t. So it will be A times sine 2 pi f2 into t. I'm just considering time dependent part since there is no any rule of x dependency in this part. So I'm just neglecting it. So on adding, you will get y equals to y1 plus y2. Now take out a as common. So you're left with sine 2 pi f1 times t plus sine 2 pi f2 into t. So this is similar to what I have done in the above part for sine c plus sine d. So sine c plus sine d is equals to 2 times sine c plus t over 2 multiplied by cos c minus d by 2. So using this relation, So y equals to a being common. On adding these two terms, it will become 2 times sine c plus d by 2, that is 2 pi f1 t plus 2 pi f2 t divided by 2 multiplied by cos c minus d by 2, that is 2 pi f1 t minus 2 pi f2 t divided by 2. On solving, you will get 2 times a sine 2 pi t being common, keep it outside. So you're left with pi times f1 plus f2 multiplied by t from this first part, cos pi times f1 minus f2 multiplied by t. So this will be a final expression on adding these two parts. Now in this part, we have two terms. First is f1 plus f2, and the second is f1 minus f2. It means on adding these two terms, there will be two different waves. One having frequency f1 plus f2, and the other will have frequency f1 minus f2. Let me show you this part. In this, we have f1 equals to 4 and f2, we had 2. So on adding these two terms, we have two different waves. One is this blue one, which having frequency, the difference of these two parts, that is 4 minus 2. That's why it is 2 oscillation. And the next one, which is green, if you count number of oscillation, this is 1, 2, 3, 4, 5, and 6, which is nothing but sum of these two terms. So we'll say the outermost oscillation will define you beats frequency. So it must be equals to difference of frequency of these two waves. So we can conclude from this part, this term will define you beat frequency. Is it clear? So beat frequency is equals to difference of frequency of two waves. That is f1 minus f2 or f2 minus f1. It will depend upon its magnitude, which is greater. Matthew, any doubt?
No, sir.
Okay, just write it down to this part. Just 1 minute. Just write. Have you all done?
Yes.
Okay. So from this part, we can say beat frequency will be difference of frequency of these two waves. For vase, just see. In first part, this is half oscillation and this is half oscillation. So this will become one complete oscillation. This is one complete, this is one complete, and this is one complete. So in total, from this point to this point, we have 4 complete oscillations. So its frequency is 4 Hertz. In second part, starting from this, completed at this point. So one complete oscillation, second complete oscillation. So we have 2 Hertz frequency. Similarly, in this part, starting from this, completed at this point, since there is no any end towards downward direction for this. So it will complete only at this point. So one complete oscillation and the other complete oscillation. So in total, we have 2 complete oscillation for this part. Is it clear?
Yes, sir. And the
Okay.
green one?
The green one, due to its resultant part, that is due to the sum of these two terms. So it is starting from this, 1 complete oscillation, 2 complete oscillation, 3, 4, 5, and 6, which is nothing but sum of these two frequency.
Okay, okay, sir. Thank you.
So beat frequency is nothing but difference of frequency of any two waves. Let me define you some concept regarding it, how to solve. First, law of frequency. On what factor frequency may depend upon? Let me define you as velocity equals to lambda into frequency. So we may write frequency is equals to velocity divided by lambda. This lambda will depend upon length, and this velocity may depend upon if we are considering transverse wave. So it will depend upon tension, mass of that particular substance. And if you are calculating in terms of longitudinal wave, that is sound wave, so it may depend upon pressure density. So related to this part, we may write frequency depends upon length of a string, mass, tension, diameter, and density. So it mainly depends upon 5 different factors. You have to remember only 2 parts. This one, frequency is inversely proportional to mass. And this one, directly proportional to tension. So if you increase mass of that particular substance, it will tend to decrease its frequency of vibration. If you increase the tension, suppose string-based instrument like guitar, sitar, on tuning, you just increase tension of it. On increasing tension, frequency of vibration will increase. So from this part, we can say frequency is inversely proportional to mass and frequency is directly proportional to tension. So there will be some process. First is waxing. It means deposition of layer of wax on tuning fork. Deposition of layer of wax on tuning fork. So due to this deposition, mass will increase and consequently frequency will decrease. Next process will be filing. Rubbing of tongue of tuning fork with any sandpaper, due to which mass decreases and frequency will increase. Rubbing with sandpaper, which will tend to decrease its mass and hence frequency will increase. And third part, for string-based musical instrument on tuning, tension increases and consequently frequency increases. Just write it down. These are called law of frequency. Have you all done?
Yes.
Okay. Let me define your question related to this part. If two tuning fork vibrates together, produces 5 hertz beats frequency. If waxing A, that produces 4 hertz, find frequency of A if frequency of B is 305 Hertz. How to solve these type of problems? Let me define you. We have two situations. In first part, on vibrating together A and B, and they produces 5 beats frequency. On second, after waxing A, they produces just 4 Hertz. If frequency of B is 305, so what will be frequency of A? Let me define you how to solve. First, you may write initially. What we have, beats frequency, 5 Hertz. Beats frequency is nothing but difference of frequency of two source. So we may define frequency difference in two different ways. First, it will be frequency of A minus of frequency of B, in which I'm considering A is greater as compared to B. But you may say it might be frequency of B greater than A. So using these two concepts, let me define frequency of A and frequency of B. Frequency of B is given 305 Hertz. So frequency of A must be 310 Hertz. Since the difference of these two terms, that is beats frequency, is 5 Hertz. Matthew, is it clear? How I get 310 Hertz for A? Okay. Similarly, if I'm considering B is greater than A, so it will be 305 Hertz, and frequency of A in this case will be just 300 Hertz. Since the difference of these two parts must be 5, that's why. So this is initial condition. Now, what will happen on waxing? On waxing A, mass of tuning fork will increase and consequently frequency will decrease. So frequency of A will now decrease. So new frequency of A will become 309 Hertz, 308 Hertz, or so on. At this point, frequency of A will become 299, 298, and so on. Now, we have to calculate new beats frequency related to new frequency of A. Beats frequency is difference of frequency of two waves. Now it will be 309 minus 305, since there is no change in frequency of B. So on subtracting these two parts, you will get 4, 3, and so on. But in this case, on subtracting 299 and 305, it will be 6, 7, and so on. Now just compare what you have given after waxing. So after waxing, frequency of combination is 4 Hertz. So in which of these two conditions 4 Hertz is lying? So you will say in this part. So this will be correct answer. Mamuna, is it clear, this entire part? Mehreen, is it clear?
Yes, sir.
Okay, just write it down. Matthew, any doubt?
No, sir.
Matthew, done?
Yes, sir. Yes, sir.
Let me define you one more thing. Stationary wave in organ pipe. Organ pipe means fluid, shahnai, these things. It may be of two types. One is open organ pipe and the other is closed organ pipe. So let me define you. In first or open organ pipe, wave will be created like this. So let me define you. This is one complete wave, and this is its overlapping part. So total wavelength will be from this point to this point. But in this part, it is about from this point to just this point. So which is nothing but lambda by 2. So define length of this organ pipe is L. So L must equals to integral multiple of lambda by 2 from this part. So if you calculate lambda, so it will be 2 times of L by N. So frequency is velocity by lambda. So it will be equals to N times V divided by 2L. In case of closed organ pipe, wave will form like this. It is nothing but, let's say this is one complete wave, and this is its overlapping part. So this is nothing but from this point to just this point, this section. So it will be just lambda by 4. Let's say length of this tube is L. So L will equals to 2n minus 1 lambda by 4. It means it will be odd integral multiple of lambda by 4. So wavelength in this part will be 4 times L divided by 2n minus 1, or frequency will be 2n minus 1 multiplied by V divided by 4L. So these are two different formula related to frequency of wave created in open organ pipe and closed organ pipe. You will be asked to find a ratio of first frequency, second frequency of whatever. So you may put the value of N and try to calculate respective frequency in these two terms. Matthew, any doubt?
No, sir.
Just write it down.